everyone. We are Team Bloom of Youth from Chongqing University, China. We are excited to be one of the finalists of the IEEE AP-S Student Design Contest. My name is Yaqi Yu.
I am Zhiyang Qi.
I'm Xinyuan Cao.
I'm Yueyang Li.
Nowadays, the COVID-19 pandemic is drawing more attentions, and the abnormal rise of body temperature is one of the most common symptoms. Based on the limitations of the conventional wireless body temperature measurement methods, such as the short working distance, we spent the last 4 months on designing a miniaturized Huygens circularly polarized tag antenna to comprehensively improve the performance of RFID system.
Here is our proposed system. We have a RFID tag module that consists of a HCP antenna and a RFID chip. This module harvests the electromagnetic energy, gain and transfer the real-time temperature. And the next one is the RFID reader module. It gets the signal through the RFID reader antenna, then process it by its sub-module, IF module and ARM chip. The digital signal after the processing is then stored and transmitted to the terminal device through the Bluetooth. Finally, the user sees the temperature displayed on the terminal device.
Here is the RFID tag antenna. It consists of a customized Huygens circularly polarized antenna and a RFID sensor chip.
The Huygens circularly polarized antenna consists of 3 subject layers. They are supported by nylon column and foams. The gain of the Huygens circularly polarized antenna is 2.32 dBIC at 915 MHz with a Huygens radiation pattern. It contributes to realize a long detection distance with a low sub-value, which can decrease the radiation influence on human body. The RFID sensor chip is EM4325 from EM Microelectronic. We have soldered it at the driving element of the Huygens circularly polarized antenna. The chip has a built-in temperature sensor that can support the temperature measurement ranging from -40 degrees centigrade to 60 degrees centigrade, with a measurement resolution of 0.25 degrees centigrade.
In addition, one of the highlights of our RFID tag antenna is its quite small size. For further comparison, we make a circularly polarized cross-dipole model for demonstration. This is the normal size of half-wavelength resonant circularly polarized antenna. This is the size of our antenna. One can immediately see the importance and advantage of the development of our electronic small Huygens circularly polarized antenna for this on-body application.
This is RFID reader module. It consists of a reader antenna and a radio frequency module. This reader antenna is a circular polarized antenna array with working band of 902 to 928 MHz. And this is a radio frequency model. It consists of an amplifier and a AD converter. We use it to amplify and convert the received radio frequency signal.
As for the control module, it includes power control module, the buzzer, serial port, the Bluetooth module, as well as ARM. The power control module is mainly composed of a power management chip, AD9221AR. It can control the system and realize the switch between the battery power supply and USB power supply. Every time the active is completed, the active buzzer makes a sound. The ARM can undertake the tasks of data processing, transmission, and storage. And the Bluetooth module can transport the data to the terminal device.
Finally, the data we get will be displayed through an app written in Java. It is really user-friendly and can be used on a phone or tablet PC with Android 4.4 or higher version. When we click the Read Tag TID, it will display the serial number, which is the ID of the current detected tag. And then we click the Read Tag Data. The measured temperature information will be displayed on the app.
Here is the setup for the system debugging. As we can see, the reader antenna connects with the RF module through a cable, and the RF module connects with the control module through a data transmission line, and the whole system connects to the computer because we will debug the system on the computer application program. After all that, we start the system debugging. Firstly, we should take the tag in front of the reader antenna. And secondly, we set the tag as passive working state and set the RF module into the right working frequency. Finally, we compensate the tag's temperature based on the reference temperature obtained by standard hospital thermometer. After hearing that sound, that means the whole debugging system is completed.
Now the volunteer wearing the tag stands 1 meter away from the reader. And we click the button to turn on the buzzer. It means that it will make continuous sounds when the tag is in the effective working range. Then we get the tag ID, and as well as the information. We can see that the temperature we get is 35.75 centigrade. Then our volunteer moves backwards. Again, the reader detects the tag, and after the same operation, we also get a temperature. The temperature we get is also 35.75 centigrade. We can find the two numbers are the same, which means that our system works steadily and effectively.
As you can see that our proposed RFID system can achieve timely, high accuracy and bio-friendly skin temperature measurement within a range of about 1.7 meters, which is long enough to satisfy the requirements of various public places. Finally, we'd like to express our thanks to Professors Chongqing, Da Yi, and Richard Rokowski for their support and encouragement.
Of course, teamwork is also essential. Everyone benefits a lot in the process of solving difficulties, and we appreciate every team member for their efforts.
At last, we are very excited to present our work in the contest this summer, and thanks the judges for considering our APS student design contest mission.